Exhaust system, once just a few pipes, and sometimes a muffler, today a true technological laboratory hidden beneath the car. This is how the first exhaust systems looked in the early 20th century. And this is how they looked in the 1970s when catalytic converters started appearing in vehicles. Let's take a closer look at modern designs. In today's factory-built passenger cars, these systems are more advanced than ever. But that's not all. A fascinating trend involves fake exhaust tips or speakers simulating a sporty sound. Why? Because diesel exhaust systems are often too quiet or simply don't sound appealing. At the same time, it's important to highlight that diesel engines emit more harmful substances than gasoline engines. That's why their exhaust cleaning systems are more complex. Let's see how an exhaust system works, what its components are, and why it's so important, not just for the vehicle but also for the environment. We'll focus on a few examples, but practically every car model has a uniquely shaped exhaust system. The exhaust system begins with the exhaust manifold, which collects gases directly from the engine's cylinders. This is the first step in the journey that exhaust gases undertake. If the car has a traditional turbocharger, it is located right after the manifold. The turbocharger boosts engine efficiency while simultaneously reducing noise. Next, the exhaust gases pass through the catalytic converter. It transforms harmful substances like nitrogen oxides, hydrocarbons, and carbon monoxide into less harmful compounds such as nitrogen, water, and carbon dioxide. Diesel engines are also equipped with an SCR system, selective catalytic reduction, which reduces nitrogen oxides by injecting a urea solution called AdBlue. Diesel vehicles use DPFs, diesel particulate filters, while gasoline engines have GPFs, gasoline particulate filters. Both effectively reduce the amount of soot and ash particles released into the atmosphere. The exhaust system also includes a set of sensors that ensure efficient engine operation and emissions control. The lambda sensor regulates the fuel air mixture, the NOx sensor monitors nitrogen oxide levels, and the temperature sensor protects components from overheating. We must also mention valves like the EGR valve, which reduces emissions, or exhaust flaps, which influence engine sound and performance. In the second half of the exhaust system, there is typically a resonator, also known as the mid-muffler, as well as the final muffler. The resonator fine-tunes the system's sound, eliminating a narrow range of undesirable frequencies, while the muffler reduces noise from the exhaust gases. Some mufflers have built-in resonators, combining both functions into a single unit. At the very end of the exhaust system is the exhaust tip, often hidden behind a decorative cover in the bumper. The components of the exhaust system are connected by pipes of specific shapes and diameters, as well as gaskets and clamps. Flexible pipes reduce vibrations and stress caused by thermal expansion. Proper mounting brackets keep the exhaust system securely attached to the chassis, preventing vibrations from transferring to the vehicle's body. Additionally, heat shields protect surrounding components from the high temperatures generated by the exhaust system. Modern exhaust systems are the automotive industry's response to growing market and regulatory demands. Their ongoing evolution enables manufacturers to produce vehicles that meet the highest standards, which is crucial in today's rapidly changing industry landscape.